Alright, this is Mr. Gillum, and today we're going to learn about dividing fractions. And to start, I want to remind everybody that a fraction bar and a division sign mean the same thing. And so these are equivalent statements. Now we talked about equivalent fractions earlier this year, as far as 1/2 is the same as 2/4, is the same as 4/8, the same as 6/12, and so on and so on and so on. But there's also different ways to represent division. And so you can represent division through a compound fraction, what's called a compound fraction. Okay, and where that is just where another fraction bar takes the place of the division sign. And so, for example, if we're taking 1/2 divided by 3, that's the same as saying 1/2 over 3. Or you could say 5/3 divided by 2 is like 5/3 divided by 2. Okay, same way here. The divide sign could be represented as a compound fraction, 4 over 2/3, or it could be represented like this: 1/4 divided by 6 is 1/4 divided by 6. Okay, and so where you see the blue and where you see the green, those symbols represent the same thing. Okay, they're just written different ways: division, 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 division. Same way with the green. And so that's one of the big things I think is hard for some students to understand, is writing things in equivalent ways. So let's just take a look at this first problem. And I don't want to solve how to divide this fraction. I just want to rewrite it a different way. So in this case, if I wanted to take 5/3 divided by 2, I could write it like this: 5/3, and instead of my divide sign, so I've written down my 5/3 and my divide sign. For my divide sign, what I'm going to write down is a big fraction bar right there, divided by 2. 2 on the bottom. So 5/3 divided by 2 written like this is the same as 5/3 divided by 2 written like this. All right, let's take a look at the next one here. 4/7 divided by 3. I'm going to write down my 4/7 first right here. And then my divide sign is this big fraction bar, and then 3. So those are equivalent statements. Or I could do 3/2 right here, divided by 2/5. All right, and so like I said, the point of this little exercise is just to show that division signs and fraction bars are the same thing. 8/9 is really 8 divided by 9, but we're going to write it as 8/9. Then my divide sign is going to be right there, and then 3/4. Okay, and now I obviously make the division bar longer, but it's going to be a little harder to tell on some of your worksheets. But there is a significant difference between the length of the bar as far as where to separate the division sign on your paper. So again, just for exercise, you can see that this fraction bar right here is just a little bit longer than the other one. Okay, it's a little more distinguished. It's just a little bit longer. See, it's a little more bold even. So I would just rewrite this as 1/2 divided by 4, or 3/4 divided by 7, or 1/5 divided by 2, or 3/7 divided by 2/5. Okay, so same thing. Means the same thing, just written a different way. And this is going to be important because sometimes you might see a compound fraction and not know what to do. But now that you know a compound fraction and a division are the same thing, you'll be able to do it. All right, one last little exercise here. We got the main fraction bars in here. That one, the bolder, a little bit longer fraction bars. I just highlighted them for you. We're just going to rewrite those problems. 7/8 divided by 9/10. 3 divided by 5/6. 2 divided by 1/8. Or 9 divided by 2/5. All right. So now that we have it separated into division, what is the process that we actually take? In this case, what we're going to do is step one, if you see that a fraction is complex, we're going to separate it using a division symbol. So I've got a little example up here in the right hand corner. It may or may not be on your paper. If it's not, I want you to write it down. And step one says separate it and using a division symbol. And this is the guy I'm talking about. So I'm going to separate it 1/3 and divide it by 5/6. And so step one is all in green there. Okay, so I've done step one, check. Now it says step two, change the division sign into multiplication. That's interesting. So I'm going to X out that division sign. I'm going to change it to multiply. And then it says invert the second fraction. So change it into multiplication and invert the second fraction. So what I'm going to do is I change it to multiplication. I'm going to invert, or I'm going to flip it over the second fraction. So now it's going to read 1/3 times, and I like the dot better, 6/5 instead of 5/6. All right. Now we're just going to multiply straight across and reduce our answer, or we can reduce, cross cancel, cross cancel. I look at 1 and 3. I don't see anything that reduces. I see 6 and 5, nothing there. Crossways 1 and 5, nothing. 3 and 6 though, they do reduce. So now all that's left is 1 times 2, 2, and 1 times 5. 5. So that fraction would be 2/5 as my quotient. 1/3 divided by 5/6. So let's take a look at a few other examples here. And we're just practicing just a basic skill here, is just dividing fractions. So now none of these are complex fractions, which is nice, but you follow kind of the same steps and process. So we already have it written as a division with the actual division sign. So the next thing I'm going to do is I'm going to write down the first number, and I'm going to change the division into multiplication. And I'm just going to use a dot for the multiplication sign. Now here's the tricky part. This 2 doesn't have a numerator and a denominator. It's just a numerator right now. But if we want it to have a denominator, we could divide it by 1, because 2 divided by 1 is still 2. So this is important for the next step, that I have a numerator and denominator, because I need to invert or reciprocate or flip over, is the easy way to think of it, the 2 over 1. I'm going to change it to 1 over 2. And now I used to have division, but I have multiplication. So what I can do is I can look for reducing. 5 and 3, they don't reduce. 1 and 2, they don't reduce. 5 and 2 don't reduce. 1 and 3 don't reduce. All that's left to do is multiply straight across. 5 times 1 is 5. 3 times 2, 6. My quotient is 5/6. What's left over after my division. All right, let's take a look at another one here. Again, I don't have a compound fraction, so I don't need to change anything. So I'm just going to say 4/7, doesn't change, divided by. That's where the first change happens. I'm going to change that to multiply. And the next part, this 3 here, doesn't have a numerator and a denominator. Right now it just has a numerator, so I'm going to put a denominator under it of 1. And the reason I can do that is because a division sign means divide, and 3 divided by 1 is still 3. Now I can see that there's that denominator down there, and I can flip that fraction over. So instead of 3 over 1, I'm going to say it's 1 over 3. All right. Now it's just a multiplication problem, which we've been practicing. So I see, do 4 and 7 reduce? No. Do 1 and 3 reduce? No. 4 and 3, they do not reduce, and 7 and 1, they do not reduce. So again, all I need to do now is just multiply straight across. 4 times 1 is 4, and 7 times 3, 21. That's what's called a quotient when you use the outcome of a division problem. So again, we'll go a little quicker this time. 3 over 2 doesn't change. The division sign does change into a multiplication sign, and the next fraction flips over. So it was 2 over 5, now it's 5 over 2. Again, I'm going to check to see, does anything reduce? Reduce, cross reduce, cross reduce, nothing. So I'm just going to multiply straight across. 15, my smartboard went nuts. 15 over 4. Done. Some of your teachers in the past may have had you change that into seeing how many times 4 goes into 15, and they might have said 3 and remainder 3. 4 3 times would be 12, and then 3 more to get to 15, so 3 3/4. Either way is fine. You can leave it either way you would like. All right, a few more examples here. Let's take a look. The first fraction is going to stay the same, 8/9. Then the divide is going to change to multiply. And then the 3/4 will flip over, change it to 4/3. Again, I'm going to check to see is there anything that reduces. So 8 and 9, nothing reduces. 4 and 3, nothing there. 8 and 3, no. 9 and 4, no, nothing there. So long as I reduce, cross cancel, or cross reduce, you're not going to find that your answer ever reduces. So it's always easier to reduce the small numbers than it is big numbers. So 32 on the top, 8 times 4, and 9 times 3 on the bottom, 27. And I know that doesn't reduce because I checked reduce, cross reduce. It's going to be the best answer. Again, you could write 1 and 5/27, but 32/27 is fine for now. This brings me to a compound fraction. I'm going to highlight that main fraction bar there. I'm going to change it to 1/2 divided by, where that big fraction is, 4. Okay, and so now I have a division problem just like I was doing a second ago. I'm going to go ahead and say 1/2 is going to stay the same. My division is going to change to multiplication. 4/1 is going to change to 1/4. And now I look to reduce. 1 and 2, nothing there. 1 and 4, no. 1 and 4, 1 and 2, nothing to reduce. So I'm just going to take 1 times 1 and 2 times 4. 1/8 is my quotient. That's a really key word, so I keep using that word. It's a really key word there. Okay, and then finally I do have another compound fraction. 3/4 divided by 7. Now it looks more like something we know how to operate with. I'm going to change it just like I did before. The 3/4 stays the same. My division sign is now going to be multiplication, and my 7, which is really over 1, is going to become 1/7. I look to reduce, cross reduce. Nothing reduces in this one. 3 times 1 is 3, and 4 times 7 is 28. I know that doesn't reduce because I already checked for reducing before I multiplied. And so now that brings us to almost our last page. Oh yeah, this is our last page. Just 3 more examples. I see this is my main division sign, so I'm going to change this into 3 divided by 5/6. So because this 3 doesn't even change, I'm just going to write it down again. I'm going to change my division into multiplication, and I'm going to flip or reciprocate or invert, all those words mean the same thing, the 5/6. Now this could be confusing because I don't see anything underneath this 3. So if I don't like to see that 3 all naked by himself, he's not on top of anything, you want a denominator on him, you could put him over 1, because 3 divided by 1 is still 3. Now I'm going to look to reduce, cross reduce. Again, there's nothing in this case, so I can just multiply straight across. 3 times 6 is 18, and 1 times 5 is 5. You could change that into 3 3/5 if you would like, but 18/5 is fine with me. Again, I want to really establish which division sign I want to separate between. So I'm going to have a big 2 divided by a 1/8. And so I'm just going to go ahead and work my process. I don't like that that's just 2 by itself, so I'm going to make it a 2/1. I'll change that division to multiplication, and I'm going to switch this 1/8 to an 8/1. Looky there. Really, this is just 2 times 8. 16. There we go. And finally, again, this is, they usually try to emphasize a little bit more the main fraction so you can see where that division goes. You could do it any way you want and make any of them the main division sign, but a lot of times they'll have one that's just a hair bigger if you really look at the details, and you'll be able to tell that that's the one they want you to separate. Okay, so let's take a look here. We have 9 divided by 2/5. So I'm going to go ahead and put that 9/1 because I just think it looks a little neater. 9/1, and the division changes to multiplication, and the 5 and the 2 switch places. They invert. And so now I just look to reduce, cross reduce, And then if there's nothing that happens, I can multiply straight across. 9 times 5, 45, and 1 times 2 is 2. Or you could say 22 and 1/2. Either way is fine. So that's it for today, dividing fractions.